The following is example 6.2 out of the textbook on page 247. Here we are asked to calculate the work associated with the expansion of a gas from 46 liters to 64 liters under a constant external pressure of 15 atmospheres. For this kind of a calculation, we need the equation for work equaling negative P delta V. The pressure is constant, the volume is changing. We need to figure out what our delta V is. Delta V is quite simply our V final minus V initial. Delta is the change in. If you're interested in the change in something, so for instance when you were little, the change in your height or the change in miles on a car, you take the final number minus some initial number that you're comparing it to. So if we do this, we get a delta V equal to 18 liters. We go ahead and plug this in to our work equation. Work equals negative, our pressure is 15, times our delta V is 18, and we get negative 270 liter times atmosphere. Now, this is an expanding gas. When a gas expands, if you were to think of a balloon expanding, you could put something on top of the balloon, and when it expands, it will get pushed up. If something gets pushed by the gas, that means that the gas is doing something. The gas is doing work. If it's doing work, then that energy is leaving the gas and going into whatever it is, whatever work it's doing. And that is the reason for this negative sign. So that when we have an expanding gas, we end up with a negative work because we have energy leaving our system. Again, this is example 6.2 out of the textbook on page 247.